Hi everyone. So the problem that I'm going to work with is called longest increasing path in a matrix. This is problem number 329 on Leetcode and it's a hard category question. So the problem statement is given an m cross n integer matrix, return the length of the longest increasing path. From each cell, you can either move in four directions, left, right, up, or down. You cannot move diagonally or move outside the bounds. Wraparound is not allowed. Example, we have this matrix and we need to find the longest increasing path in the matrix. So how do we go about solving this problem? Um, so we need to run a DFS through every single element of the matrix in order to find the longest path. Um, so, for example, let's say let's say we start here. We are allowed to go right, up, down, and left. So let's see what we can do here. Um, so if we start at this cell, can we go to the right? We cannot go to the right because it's the same number 9. We cannot go up because it's out of bounds. We cannot go to the left. We cannot go down. So out here we cannot go anywhere. So what we are going to do is we are going to have a helper array of the same dimensions, a matrix of the same dimensions as the given matrix. We are going to call this LIP, longest increasing path. So for this square, the longest increasing path is just 1, right? So now what we do is we go to the next square, which is 9. So we are going to run a DFS on this. Uh, we cannot go to the right, we cannot go up, we cannot go left, we cannot go down. So we store the result as 1 in this matrix, right? So the next step is we have to run the DFS on this 4. So from here we can go to the left and yeah, that's all we can go. We can go to the left. So what is the LIP for this? It would be 1 plus 1, that is 2, right? But we can also go down, right? But we haven't explored 8 yet, so we need to explore 8 now. Yeah, so from 8 we cannot go down, we cannot go to the right, we cannot go up, and we cannot go to the left. So at this position we have to store a 1 because yeah, we cannot go anywhere from here. And this LIP is also equal to 2. So from 4 we can either go to the left or to the down, to below, and the longest increasing path is the same, which is 2. So we just store 2 in this array, in this matrix. So the next step we start is the exploration of 6 out here. We cannot go to the bottom, we cannot go to the left, we cannot go to the right, we can go to the top, right? We go to the top and we encounter 9, and at this position we know that the LIP for 9 is 1, so the overall LIP for 6 would be 2, so we store 2 in this array. Now the next we go to this 6. Yeah, we can go to the right. So we encounter 8, and we know that the LIP for 8 is 1, so LIP for this part would be 1 plus 1, that is 2. But we can also go up, right? So when we go up we encounter 9, and the LIP for this 9 is also 1. So if we go this way, the LIP is 2, so we'll just store 2 out here. uh, the next thing we are going to do is we are going to explore 2. So from 2 we cannot go to the right, we cannot go down, we cannot go left, we can go up, and we encounter 6. We already know that LIP for 6 is 2, so the overall LIP for this square, that is 2, would be 2 plus 1, that is 3. So we'll just store 3 here, right? Next we'll go at 1. So from 1 we cannot go to the right, we cannot go down, we can go up. If we go up, we encounter 6, and the LIP for 6 is 2, so 2 plus 1 would be 3. If we go up from the square, it would be 3. Um, let's see another path. If we go to the left, we encounter 2, and we know the LIP for 2 is 3. So the LIP for this element 1 right here is 3 plus 1, that is 4. 4 is greater than 3. Max of 4 and 3 would be 4. So we'll store 4 here. Now we explore this cell. We can go up. We encounter an 8, and we know the LIP for this 8 is 1. So the LIP for 1 would be 2. So our answer is the max of this matrix, which is 4. 4 is our output here, right? Yeah. So let me explain the code. How do we go about solving this? We can solve this using dynamic programming with memoization. So we just need to run a DFS on every single element, right? And we need to store the result, and that's how we get our answer. So here is the source code. I'm gonna explain this code. So first we are defining max as 200, and then we are defining this matrix. And then we have this matrix with the dimensions 200 x 200, and then we have this DP matrix. This DP is where we are gonna store our solution. And then we have in variables n and m, these are the dimensions of the matrix. You know, it's an n cross m matrix, or m cross n. Then we have this dx and dy, which gives us the directions, whether we are going down, up, left, or right. So dx and dy is dx is for left and right, and dy is for up and down. Okay, and then we have this function int max, which will just return the greater of the two values, because we need that, right? If one value is bigger than the other, we need to select the max of the value. And then we have this function, which is DFS. This is the most important function out here. Yeah, so we need to run a DFS on every single element of the matrix. The data structure that we can use to solve this problem is called a DAG, a directed acyclic graph. What we can do is we can consider every single cell in the matrix as a node. And from that node, we can run a DFS on every single element, and then we can store the result. So it's a DP+ memoization problem. Um, so DFS, we have int I and int j. So now this is the base case. If it is already computed, if we have already computed the LIP, we are going to return this dp of ij. Okay. The next case is answer is equal to 1. That is, if the minimum path length is 1, which is the cell itself, right? So yeah, first we are initially storing answer as 1, and then we are going to explore in all 4 directions. So we are taking a loop int d is equal to 0, d is less than 4, And then ni is equal to I plus dx of d. This will explore in the left and right directions, and this nj j plus dy of d, this is going to explore up and down. And now what we're doing is we are checking bounds. Okay, we are checking if the number is going out of bounds when you move left, right, up, down, or and we are checking the increasing condition as well. If the number to the up, down, left, or right is greater than the current number, what we do is we store answer as max of answer, comma 1 plus dfs of ni nj, right? So this will store the value, um, this store the value of the longest increasing path. And then what we're doing is we are storing this result in this dp matrix, right? And then we are returning the thing. And then we have the main function to compute the result. This function is longest increasing path. Result, we are initializing result as 0, and then we are running a loop through the n cross m matrix, and we rewrite this result is equal to max of result dfs of ij. dfs of ij returns this answer. So first we are storing result as 0, and then this statement will store the longest increasing path in this result, and then we are returning the result. So we'll get 4 in the given problem as result, right? Yeah. So next is main. We are defining n and m as 3. We are taking this the same example 994668211, and then we are initializing the matrix and dp. So we have this loop matrix of ij is equal to temp of ij. dp of ij is -1. So initially we are storing all of this as -1 because it's unvisited, right? And then we write this answer is equal to longest increasing path. So we are going here, the function longest increasing path, and then it will uh, calculate the result, and then it will return the result. And then we print longest increasing path length is equal to answer, which is 4 in the given question, and this way we will have our answer. So we can try running this code somewhere. Yeah, so we have our result as longest increasing path length is 4. So we can understand with another example. Here we have this matrix 3 4 5 3 2 6 3 2 1. So we could we don't know where to start, right? So we could start at any matrix, and then we can explore all the other places that we can go. So this is a DFS approach we can use to solve this. So if we start at 1, let's see, we can go to the left, and then we cannot go anywhere. So this case the DFS would be 1 plus 1, that is 2, and we can go up and then we cannot go anywhere, so it's 2, right? So out here we are going to store we are going to store 2 at the adjacent place of 1, right? So if this is 1, 2, 3, 1, 2, and 3. So 1 is at 3 comma 3. So at 3 comma 3 we store 2. Then we go to 2, and then we run a DFS on this. We cannot go to the left, we cannot go up, so it's just 1. And then we go to this 2, we run a DFS on this, we go up, and then we can't go anywhere, so it's just 2. So we are at 3. From 3 we cannot go anywhere, so it's just 1. We are at 2. From 2 we can go to the left, we can go up, we can go to the right. At left we know it's 3, and at 3 the LIP is 1, so this will just be 2, right? At the right we reach 6. If we explore 6, we'll see that we cannot go anywhere, so for 6 the LIP would be 1 as well. So if we go to the right we encounter 6, so the LIP would be 6. Next, if we go to 4, we'll see that from 4 we can go to the right and we reach 5, and from 5 we can go to 6. So for 5 the LIP would be 2, for 4 it would be 3. So if we go from 2, 4, 5, 6, the LIP is 4, right? Yeah, so it's 4. Now we can explore this 3. From 3 we can go to the right and we reach 4, and we know that LIP for 4 is 3, so the LIP for this position would be 4. So in this case we have two answers, that is we can move either from 3, 4, 5, 6, or we can go 2, 4, 5, 6. It's gonna give us the same result. So the complexity for this could be big O of m cross n, right? Because we are smartly storing the solutions of the previously found LIPs and we are using them in the next situation. If we use the brute force approach, it would be exponential time. Yeah, so by using dynamic programming, we can significantly reduce the time complexity from exponential to uh, to polynomial time. So yeah, this was the approach for solving this problem and the source code. Thank you, everyone.